I just want to go over the calendar a bit more. We're going to be spending time going over curve sketching today. So a lot of, we'll do a full curve sketch problem from chapter 3. We'll review mean value theorem, but from a trig perspective. Right? Thursday, we'll do related rates. Friday, we'll do inverse trig derivatives. So we still have 3 big topics to go over. I had a chapter 5 recovery help session this morning. That session is recorded. So I have it under today's date. And I have another one, chapter 5 session at 7:30 a.m. and also Monday as well. All right, there's 3 versions of the test, so I'll work through each of the different versions on each of the days so that if you want some additional practice, you can sit in on those sessions or watch them and work through them at your own pace. Okay, so that'll be so that's what's coming up. Now, some of you have not been here. You're out of town, so let me just kind of go through details for that chapter 5 recovery. So one option is you can prepare for the recovery test and take it next Tuesday. Okay, so next Tuesday, that recovery option, you can either come in the morning 7:15 or after school at 3:30, take that recovery test, and then you can earn back up to the 79 on that recovery test. The other option is you don't take the recovery test and you wait to see how you do on the trig unit test. Right? That trig unit test can replace the lowest test grade. Okay. That's the second option. Third option is if you missed out on this recovery test and the trig test you're not happy with, then you can come in that last week of school. I don't have anything planned on that week, so you can come in, get help sessions from me, ask questions, go over problems, or you can do makeups or recoveries on any of those days there. So do a trig test recovery. I hope to get that trig unit test graded by Monday, if not the latest Tuesday, so that you can have time to study. If you want to take it either Thursday or Friday, you can just come in the morning to take it. Okay. Or you can do a chapter 5 recovery test during this week as well. Yeah, any questions? Yeah. All right, so today we're going to just focus on curve sketching, or chapter 3. We're going to skip 1 and 2, and we're going to go to number 3 on that handout that you guys have in front of you. Just wanted to review a little bit with mean value theorem. So mean value theorem, the purpose is to find the location on the curve where a guaranteed slope is going to exist. So first thing we do is we have to make sure that our graph is continuous on the closed interval and differentiable on the open interval, right? So we've been practicing writing out those conditions. And then the next thing we do is we take the endpoints that's given to us, and we take the time to find the y value so that we can find the slope. Okay, so first thing we do is we always find the slope between the endpoints. So no calculus at the beginning, no derivatives at the beginning. We're just plugging in the x values, get the y values, get the slope. Okay, so we're trying to target what this value is. We want to know what is the slope between the endpoints. Once we can find that value, then we can find the derivative, and then from the derivative, we can set the derivative equal to the slope that we're trying to target, and then we can find the location where that slope is going to exist. Okay, so let's try number 3 here. Okay, so it says determine whether or not mean value theorem applies to the function f of x equals sine of 2x plus x on the interval from 0 to 2 pi. Okay, so first thing is we look at that sine of 2x plus x, and we know that that's just a smooth curve, right? Sine graph does not have any vertical asymptote, doesn't have any sharp turns. We can go ahead and write out our conditions, or both our conditions will pass. Okay, so here's the mean value theorem that we're going to apply. Okay, first things first, we're going to find the slope. Find slope first. So no derivative. We're just going to take the x value endpoints that they give us and find those y values and find the slope. So let's find our 2 endpoints, f of 0. Sine of 0 is 0. 0 plus 0 is 0. And now f of 2 pi. Sine of 4 pi is 0. 0 plus 2 pi is 2 pi. So there we have our order pairs. Okay, from our order pairs, we can find slope. Change in y over change in x. y2 minus y1 over x2 minus x1. Okay, slope equals what? What's 2 pi over 2 pi? Just 1, okay? So we know that somewhere along the graph, we know there must be a slope of 1. Okay? We're trying to figure out where are all the values. There's at least one, but there could be multiple ones where the slope is equal to 1. So we're done with this portion. We found the slope, we found the endpoints, and now we're moving on to the derivative. Okay. After we find the derivative, then we can set them equal to each other. Okay, so f prime. All right, so sine of u becomes cosine of u times u prime. So sine of 2x becomes what? Cosine of 2x times 2, okay? X becomes 1. All right, so we have our derivative. And now we can move on with our mean value theorem, right? We have our slope, we have our derivative, and now we'll set them equal to each other. Okay, we'll set them equal to each other here. All right, so now if we solve for x, we can find locations on the curve where there's a slope of 1. Subtract 1 from both sides, we get 0. Divide both sides by 2. Okay, so on the key is attached on the next page there. I did this a different way. I expanded this out of double angle, but I want to just keep it in double angle here and go from this perspective. Okay, so if I want to solve for x, I want to get that 2x away from that cosine. So the way we can do that is we can involve the inverse. Inverse will kind of push it to the other side. So I'm basically going to take the inverse of both sides here. I'm going to be left with 2x is equal to inverse cosine of 0. So what this is basically saying is, where is cosine of theta equal to 0? That's basically what this is asking. Okay, where is cosine of theta equal to 0? So if you think about unit circle values, where is cosine equal to 0? Pi over 2 and 3 pi over 2, right? X value is 0. But the issue here is that we want all the values between 0 and 2 pi. Right now it is, but the fact is that when we divide by 2, these measures will shrink, will compress. So what we want to do is we want to have more than what we think we need, so that when they compress, we can make sure that we didn't miss out on any ones that have been pushed in. So I want to find more coterminal angles. So that means we have to go past 2 pi, because we have to end up dividing it out. So the way we can find it is we're going to add 2 pi. Okay, and if I add 2 pi, I can match common denominators there. I can add 4 pi over 2. So I'm just going to give different variations past. So 5 pi over 2, 3 pi over 2 plus 4 pi over 2 is 7 pi over 2. Maybe I've done more than I need, but I'm going to keep going here just so I can make sure. I feel it's always good to have more than you think you need, because that way you can always make sure, okay, if you can eliminate ones that are outside the interval, that means you've taken care of all the ones leading up to it. So if I keep adding pi over 2 pi or 4 pi over 2, next up is 9 pi over 2 and then 11 pi over 2. So I want to solve for x. I want to divide by 2. Dividing by 2 seems a little messy with all the complex fractions here. So dividing by 2 is the same thing as what? Multiplying by 1/2. So it feels a little bit easier to just multiply by 1/2. So let's see what x gives us here. I'm just going to multiply every one of these measures by 1/2. I get pi over 4. So all these values are shrinking. Okay, I only want my values up to 2 pi. So which values, do you see any values that's outside the interval that we don't want to keep? What's more than 2 pi? So in other words, 2 pi is like 8 pi over 4, right? So do you see anything that's greater than 8 pi over 4? Yeah, so you see that 7/4 is less than 2, so we keep it, but 9/4 is greater than 2, right? You know that 8 pi over 4 is over here. That's our interval there. So 9/4, 11/4 is outside of 2 pi. So, but it's good that we're removing. That means we know that we didn't miss any, right? We got everything up to that point. Yes.
How did sine 4 pi?
So sine of 4 pi is same thing as sine of 2 pi. Because 2 pi, 4 pi, 6 pi, those are all, anything that is 2 pi apart are always going to keep repeating itself, right? So yeah, so sine of 0, sine of 2 pi, sine of 4 pi, sine of 6 pi is always just going to be, yeah. Okay, good. Any questions? All right, so let's go to the back. We'll do a full curve sketching problem here. Okay, so number 4 says, given the function y equals x minus 2 cosine x on the interval from negative pi to pi, find interval increasing, decreasing, relative max, points of inflection. So we're going to find y prime, create our slope sine line, find y double prime, create our second concavity sine line, and then find all the information that we can, gather some order pairs, and then plot our graph. Okay. Okay, so we start off by finding f prime. X becomes 1. What does cosine x turn into? Yeah, negative sign, right? So the 2 negatives cancels out to be positive. Okay, so there's our f prime. Okay, we'll set f prime equal to 0 to find our critical points. Solve for x. Okay, so think about unit circle values. Where is sine going to be negative 1/2? Which quadrants? So sine is going to be negative in the 3rd and 4th quadrant, right? Variations of pi over 6. So what's the variation of pi over 6 in the 3rd and 4th quadrant? 7 pi over 6 and 11 pi over 6, yeah. But the issue is that our interval is only from negative pi to pi. So if I were to create my sine line, seven pi over 6 and 11 pi over 6 is going to land outside here, right? So we're not going to be able to put them onto the sine line. However, we can always find coterminal angles by either adding or subtracting 2 pi. So if we subtract 2 pi from both these, maybe they will end up landing inside the interval, right? So let's try that. So if I subtract 2 pi, match common denominator, the same thing as minus 12 pi over 6. Okay, so that's safely inside the interval, right? That's greater than negative pi. And then we can do that with 11 pi over 6 as well. Okay, so we have coterminal angles that are relevant because they are landing inside our interval. So here's negative 5 pi over 6. And then we also have negative pi over 6. Okay, next up, we want to pick values in each subinterval to test against the derivative function so that we can gather information about the slope. So right now, it's tough to find something between negative pi and negative 5 pi over 6. We'll leave that alone. We'll go from figure out what I can do between negative pi over 6 and negative 5 pi over 6. So here's negative pi over 6. Here's negative 5 pi over 6. Somewhere between, maybe I can choose negative pi over 2. And then between negative pi over 6 and pi, I'll just choose 0. Anytime I can involve 0, it just makes it easier. Okay, it's a little bit strange to find something here, but let's just worry about these two first. So negative pi over 2, I'm going to insert this into the derivative, right, because I want to know slope information. So sine of negative pi over 2, what's that going to be? Basically sine of 3 pi over 2, which is negative 1. Negative 1 times 2 is negative 2. Negative 2 plus 1 is negative. So negative, I know my graph is going to be falling. Okay, plug 0 in. 0 in for x. Sine of 0 is 0. 0 times 2 is 0. 0 plus 1 is 1. Okay, it's tough to find something between negative 5 over 6. However, I'll tell you that with our trig function that's given to you, all the graphs will oscillate. Basically, any critical point is going to be relative max, relative min. So our graph is always going to oscillate between these points, even if it's tough to find. If you find one of them, you can just change the sign. You just keep alternating the signs. Okay, so this one will be positive here. Okay, let's list out all the related information from the slope sine line. We can make statements about interval increasing. We can make statements about interval decreasing. We can identify relative max, relative min. We can find order pairs. Okay, so let's do all of that. As well as practicing writing our because statements. Okay, so increasing, we have two intervals of increasing. Okay, decreasing. Okay, we also know there's a relative max. We'll leave some space for the y value. It'll be a little messy here, but we'll find that out later. Because f prime changes from positive to negative. Okay. We also know there's a relative minimum, right? Decrease to increase. Okay, we're going to find the order pairs here. So where do we plug this in to find order pairs? Back to the derivative or the original? Original, right? We want to find a physical location. We're done with the derivative. We've filled out our slope sine lines. Now we want a physical point. Okay, so back to the original function here. Okay, negative 5 pi over 6 minus 2 cosine of negative 5 pi over 6. Okay, cosine of negative 5 pi over 6, that's same thing as cosine of negative, same thing as cosine of 7 pi over 6, right? This is in the third quadrant. Cosine is negative in the third quadrant, and cosine is going to be root 3 over 2, right? Negative root 3 over 2. Okay, so negative 5 pi over 6. The negatives cancels out, the 2's canceled out. I'm just left with plus root 3. Now, this looks like a messy number, which it is, but I want us to be able to at least ballpark our values even without a calculator, okay? What do you know about pi? Pi is close to what? 3, right? So let's just use 3 here. Negative 5 times 3 over 6. Now, I'll give you some guides here. If you don't recognize some radicals, I'll give those to you. So root 3 is around 1.7. So think about negative 15 over 6. Negative 15 over 6, that's a little bit more than negative 2. Right, maybe that's like, but we really don't care about how close we are as long as we have some ballpark values. Okay, so we just want to have some idea where to graph our y value, right? It doesn't have to be completely accurate, but I want you to at least be able to look at a value or look at a number and just be able to estimate where it could be. It doesn't have to be exact, just I want you to have some idea where these values are. Okay, same thing, relative min. We can insert this into the original function. Cosine of negative pi over 6, that's the fourth quadrant. Fourth quadrant is going to be positive for cosine, so root 3 over 2. So here we get negative pi over 6 minus root 3. So think of this as negative 3 over 6, so that's negative 1/2 minus 1.7. That's around like negative 2.2 or negative 2. All right, all we want is just some idea where it lives for graphing purposes. Okay. So we've gathered everything that we can gather from the derivative level. Now we're moving on to the second derivative level, f double prime. Okay, f double prime. 2 sine x becomes what? Or 1 goes to 0, right? 2 sine x becomes, what's the derivative? Sine becomes what? Cosine. Set that equal to 0. Divide by 2. Okay, so where's cosine equal to 0? Okay, where's cosine equal to 0? Pi over 2 and 3 pi over 2, okay. We might need to make some adjustments. These may not fit inside the interval. If it doesn't, we can always add or subtract 2 pi to see if it ends up fitting. Okay. So pi over 2 is safe, right? We know pi over 2 is here. But 3 pi over 2 is outside the interval. So it's a little bit too far to the right. We can always subtract 2 pi, though, see if it ends up living inside our interval. So if I do 3 pi over 2 minus 4 pi over 2, what does that give me? Negative pi over 2. And negative pi over 2 is safely between negative pi and pi, so we can put that here. Okay, now we're ready to pick some points to test against our second derivative function. So between negative pi over 2 and negative pi, we can choose negative 3 pi over 4, right? Or any of those options. Between negative pi over 2 and pi over 2, I'm always going to involve 0, it just makes it easier. And then between pi over 2 and pi, we can choose 3 pi over 4, right? Second quadrant value. Okay, we tested against the second derivative function. Cosine of negative 3 pi over 4, that's the same thing as saying cosine of 5 or 5 pi over 4. We know cosine is going to be negative in the third quadrant. That's negative root 2 over 2. So 2 times negative root 2 over 2 is going to be still negative. So negative is concave down. Okay, moving on to 0. Cosine of 0 is 1, so that's positive. Cosine of 3 pi over 4, that's the second quadrant. Cosine is negative in the second quadrant. 2 times negative root 2 over 2. So concave down. Okay, we can make our statements about intervals concave up, intervals concave down. I'll leave that for you guys to fill out. I just want to do the point of inflection here. We have 2 points of inflection because these critical points have change in signs on either side. All right, let's find those y values. Back to the original function. Well, the nice thing is cosine of negative pi over 2 is the same thing as cosine of 3 pi over 2, which is 0, so all that goes away. And you know negative pi over 2 is around negative 1.5, just for graphing purposes. Okay, let's find the order pair for pi over 2. Again, cosine of pi over 2 will wipe out to be 0, so I'm just left with pi over 2, which is around 1.5. Okay, let's move into graphing. So, everybody good so far? Oh yeah, let's go ahead and write out our concave up, concave down, right? We can say concave up. This interval here. Concave down, and these two intervals here. So less than 0. All right, let's go to the sketching of our graph. I'm going to use the second page here. All right, so to sketch our graph, I want to sketch a graph between negative pi and pi. So I want to find the order pairs there, or at least some idea, so that I know where to start on my graph. Okay, just to have some ballpark value here. So f of negative pi is negative pi minus 2 cosine of negative pi. So that's negative pi plus 2. That's the exact value, but just to ballpark value, I can think of that as around like negative 1-ish. All right, f of pi. Pi plus 2. 3 plus 2, that's around 5. Okay, so at least we have an idea where we can put some of these points here. So let's go ahead and do that. Here's my f of x graph. I'll have negative pi sitting here. I'll have pi sitting here. I'm going to start here, and I'm going to end here. Okay, so let's just plot all the points that we've gathered from before. We know our relative max, negative 5 pi over 6 will be around negative 0.3, so I'll put that closer to here. And negative pi over 6, I'll be at negative 2. So I always encourage us to sketch sketch the graph very lightly, just from your sine line, right? We don't want to feel like it's too complex, right? The point of inflection, concavity can all be brought into our rough sketch, but just from this alone, we have an idea how the graph is going to move. We may not know the curvature, but we know the rise and fall of our graph, right? Okay, so now we'll bring in our second derivative information. We know that there is a point of inflection at negative pi over 2. I know negative pi over 2 is going to be somewhere here, right? Somewhere between negative pi over 6 and negative pi over 6, and negative 1.5, so that's somewhere here. Okay, so I'm going to target that point. I know that's where my curvature is going to change. And there's another point of inflection at pi over 2, 1.5. Okay, we know our graph is going to start off concave down. Then it'll shift to concave up between negative pi over 2 and pi over 2. And then it'll go back to concave down. Okay, any questions? Okay, I know it's a lot, but that's why we have all those days for review, right? When we get to next week, we can every day we can do at least one of these problems until you feel comfortable because you've seen enough of it. Okay. Tomorrow we'll do related rates. Friday we'll do inverse trig. 4 days of review next week, and trig test next Friday. Okay, next Friday. You guys have homework tonight over a few problems, over a few curve sketching problems. All right.